Alright, so in this video we're going to talk about how to develop our null and alternative hypotheses. So remember, it's important to know these because if you don't know exactly what your hypotheses are, and then you're saying we're rejecting the null but you don't really know what your null is, then you really can't come to some conclusion in terms of understanding your population parameter and the statement that you're making about it. So I think hopefully up until now the videos that we've looked at kind of help make it clear, but there are a couple different scenarios in terms of writing your null and alternative hypotheses. So I just want to have this video to make it a little bit more explicit in terms of how to write them. So in the first scenario, remember the null hypothesis basically says there's no difference, there's no effect, the effect is 0 or nothing, which is what null means. So this is the case where we have some type of new product that we're coming out where we're saying that it's better than the old one. So the null hypothesis in these scenarios would be that the new product is no better, like miles per gallon. Right? We came up with a new system that is not better. The example we used with a cell phone battery life, we'd say that the new cell phone does not last longer, right? It's that there is no effect, no result. So here's a bunch of other examples if you read this. So say we came up with a new teaching method, and we think it's better than the current method that we're using. So the alternative hypothesis would be that the new method is better. The null would be that the new method is no better than the old one. As another example, we come up with a new Salesforce bonus plan that hopefully increases sales. So the alternative would be that the new bonus plan increases sales. The null would be that the new bonus plan does not increase sales. As another example, a new drug is developed with the goal of lowering blood pressure more than the existing drug. The alternative hypothesis would be that the new drug lowers blood pressure more than the existing one. What would the null be? I hope you get this pattern by now. It would be that the new drug does not provide lower blood pressure than the existing drug. So these are just examples. Remember, you have your null and you have your alternative hypothesis. So these are statements. Obviously, when we go to write them, you have to be explicit in terms of some type of value. So mu would be less than or equal to or greater than, and then some type of numeric value so that we can assess the statements quantitatively. So in the second scenario, sometimes the null hypothesis is an assumption to be challenged. So sometimes these are cases where we're looking at production processes. So in these cases, we begin with a belief or an assumption that a statement about the value of a population parameter is true. And in these cases, typically we want the null to find support that the null is true. We would like to find that support because if we do, that basically means that our production process is working properly. In the other cases, typically we would like to find support that we can reject our null. So if we look at some of these examples, right, if we come up with a new teaching method and our null hypothesis is that the new method is no better, well, we'd like to reject that null hypothesis. We're hoping that if we came up with a new teaching method that's more effective, we'd like to find support for that statement by rejecting the null hypothesis. So in these cases, typically we would like to find support that we can reject the null. In these cases, typically we'd like to find support that we shouldn't reject the null hypothesis. So let me give you an example to help understand this. So let's say that we have a soda bottle that we look at, and it says that it contains 100 milliliters. So obviously every bottle doesn't have exactly 100 milliliters in it. Production processes make it pretty close, but the whole idea is right, the mean of the sampling distribution is equal to 100 milliliters. That's what it's basically saying. So when we go out and we calculate our sample statistic, it's an estimate, right, of our true population parameter. So again, in the realm of null hypotheses, right, we would begin by assuming that this is true, right? So the null hypothesis would be that the average, right, of how much soda is in the bottles is equal to 100, if not greater, right? If it's more, we might be okay, because typically, right, if a bottle says it contains 100 milliliters, it should. If it doesn't, right, and right, remember we're talking about the mean of the sampling distribution, or the true population parameter. That's what we're looking at. If it's not then basically, what is it, the Federal Trade Commission, the FTC, you're basically in violation. You're basically saying something that's not true. So in this case, you know, it's okay if the mean is at least 100, because then you're basically, you're not lying, right? You're fulfilling your promise that you are giving consumers something that's written on the bottle, basically, is what we're saying. So in this case, that is our null hypothesis, and we'd like to provide, find support for this statement, because if we don't, this means we're underfilling bottles. So again, in this case, right, when we have these production processes, our null hypothesis is that right, we begin with the belief or assumption that the statement about the value of a population parameter is true. So if we're saying that the bottles contain 100 milliliters, right, that is, we're assuming that that's true, and that is what our null hypothesis is, right? That the average is at least 100. So then the alternative is the opposite, that mu would be less than 100. In this case, right, we would be underfilling our bottles. So if we reject the null, like I just said, the company filling the soda bottles is underfilling the bottles, and they need to fix the problem. If we do not reject the null, the company is adequately filling the bottle and no action is required. So these are the two scenarios basically where of how we write our null and our alternative hypotheses. And typically, if we want to provide support for, or excuse me, if we want to find, I don't know why I keep saying provide, we want to find support in terms of rejecting the null or not. So again, typically in the first case, right, if we have some type of new technique, we'd like to find support where we can reject the null and basically find support that our new system, whatever it is, our new drug, our new bonus plan, our new teaching method is effective. And in the second scenario, if we're looking at something like production, manufacturing, we have some type of statement that's our null, and we'd like to find support that we can't reject that null hypothesis, because that would provide support that we're adequately filling bottles or manufacturing our products. So that's just an overview of null hypotheses and alternative hypotheses and how to write them. Remember, it's important to know what they are, because that's what you're testing. So if you don't understand that, it's hard to come to some type of conclusion because you don't really know what your hypotheses are. So first step, very important.